we're going to do a whole bunch of practice problems so you'll get super good at looking at a Lewis structure like this and figuring out what its three-dimensional Vsepr shape would be. We'll start out right away with PF3. I've got on this paper these 4 questions, and these are like the thought process that you want to go through every time you figure out the Vsepr structure for one of these shapes. Okay? So, the first question here is, how many things are there around the central atom? The first thing you always want to ask yourself. How many things are there around the central atom? Here's the central atom. It's this P here. And it's surrounded by 1, 2, 3 bonds and 1 lone electron pair. So the things around the central atom, they can be either lone electron pairs or bonds. So the point is 3 bonds, 1 lone electron pair, 4 total things. Okay, so now that we know how many things surround the central atom, 4 in this case, we ask, what structure is this molecule based on? And what I mean by that is, what if all 4 of these things surrounding the central atom, what if they were all other atoms? Okay? If they were all other atoms, we'd get this shape, a tetrahedral shape, where we have 4 atoms surrounding a central atom. We call this tetrahedral. And because this has 4 things around the central atom, we say that it's based on this tetrahedral structure. Now here's what's important. In PF3, only 3 of the things that surround the central atom are other atoms. One of the atoms from this tetrahedral structure has been replaced by a lone electron pair. Here's what I mean. This is what PF3 looks like. See that it's very similar to the tetrahedral shape. There are 4 things that surround this, but one of these atoms from the tetrahedral shape has been replaced by a lone electron pair. So the 4 things in tetrahedral are 4 atoms. The 4 things in PF3 are 3 atoms and 1 lone electron pair. So this shape looks kind of like a pyramid from the side, and we call this trigonal pyramidal. It's what we get when we have 4 things around a central atom, 3 of them are other atoms, and 1 is a lone electron pair. Let's talk about bond angles really quickly. So in tetrahedral, the angle between every pair of bonds is 109.5 degrees. That's when we have all atoms around the central atom. But when we got unshared electron pairs, these unshared electron pairs, they push a little harder against these atoms. Unshared electron pairs, they need a little bit more space than regular atoms do. So what that means is that all of these atoms are going to get pushed kind of in this direction. And so the angle between them, this bond, is going to be smaller because they're moving in this direction. So for the trigonal pyramidal shape here, instead of 109.5 that we'd have in the tetrahedral, we get an angle that's a little smaller than that and is more like 107 degrees. But just keep in mind that it's similar to 109.5, it's just been compressed a little bit because of these unshared electrons that are pushing on the bonds a little bit more. NO2, and the whole thing is an ion, it has a 1- charge. Charges don't have any impact on the Vsepr shape though, so don't worry at all if you see something that has a charge. We just want to go through this thought process. Number 1, how many things are there around the central atom? So single bonds and double bonds, they count for the same. Doesn't matter what type of bond it is. All that matters is that it is a bond, okay? So we have 1 bond, 2 bonds, and then 1 unshared electron pair. So for this molecule, we have 3 total things around the central atom. 2 bonds, 1 unshared electron pair. 3 total things. So now that we know we have 3 total things, we ask, what structure is this molecule based on? In other words, what structure would have 3 things around a central atom and all of them would be other atoms? That would be this shape, which is the trigonal planar shape. It's 3 atoms around a central atom, and all of them are lined up in this plane, which is why we call it trigonal planar. Okay. Now on to number 3. Which atoms from this structure are replaced by lone electron pairs? So NO2 has two bonds to oxygen, these two oxygens, but then it has this lone electron pair. So that means that one of these three atoms is replaced by a lone electron pair in NO2. So the structure is going to look like this. All right? Look at how similar it is to the trigonal planar shape, but this atom here has been replaced by the unshared electrons that are up there. So that is going to give us this bent shape. Now when we talk about angles in the trigonal planar molecule, there is a 120-degree angle between all of these bonds. This unshared electron pair in the bent molecule, though, pushes these atoms a little bit harder than this atom does, because unshared electron pairs like to have a little extra space. So that means that in the bent molecule, these atoms are going to be a little bit closer to each other. The angle is going to be less than 120 degrees because of this pushing. It's going to be more like about 116 degrees. Okay? So that's a bent molecule you can get when you have two bonds and one lone electron pair around a central atom. NO3 1-. Remember, don't worry at all about the charge on this molecule. It doesn't matter for Vsepr at all. The first question that you should ask yourself is, number one, how many things are there around the central atom? There's a double bond here. Doesn't matter that it's a double bond. It's just a bond. So there are 1, 2, 3 bonds to other atoms around the central atom. So that means that for number 2, what structure is this molecule based on? It's going to be based on the trigonal planar shape, which looks like this. Okay, trigonal planar. Now, for number 3, which atoms are replaced by lone electron pairs? For NO3 1-, none of them are replaced by unshared electron pairs. 3 atoms surround the central atom. So that means that this molecule has this shape. It is trigonal planar with 120 degrees between each of the atoms. OF2. Number 1, how many things are there around the central atom? Okay, there are 2 bonds, and then there are 2 lone electron pairs. So that means that there are 4 things total around this atom. So what structure is this molecule based on? If you have 4 things around a central atom, your structure is going to be based on the tetrahedral shape. Now, for number 3 here, it asks which atoms are replaced by lone electron pairs. There are 4 atoms here in red in tetrahedral, but in OF2, there are only 2 atoms surrounding the central atom. The other 2 atoms have been replaced by these unshared electron pairs. So that means that OF2 is going to look like this. Here are the 2 lone electron pairs, this one and this one. These 2 lone electron pairs that have replaced 2 of these atoms in the tetrahedral structure. So if we look at it from the side, it looks a lot like the tetrahedral shape. But it's missing, you could say that it still has these 2 atoms, but it's missing this atom and this atom. They've been replaced by these unshared electron pairs. This is going to give the molecule a bent shape. And for angles, these unshared electron pairs are going to push these atoms together harder than other atoms would, okay, because those unshared electron pairs need a little bit of extra space. So in a regular tetrahedral molecule, the angles between the bonds are 109.5, but in the bent, where these are pushing harder, it's going to be more like 105 degrees, because we have 2 electron pairs that are pushing. So they really push these 2 atoms closer together. So we get a bent molecule with 105 degrees when we have a central atom surrounded by 2 bonds and 2 lone electron pairs. HCN. How many things around the central atom? Got 1 bond here, 1 triple bond here. Doesn't matter that it's a triple bond, it's just 2 bonds. A bond here, a bond here. So if we have 2 things around a central atom, the structure is based on this linear thing that we've got here. Here's a central atom, atom on the side, atom on the side. Which atoms are replaced by lone electron pairs? None, because we got an atom here and an atom here. So that means that the final shape is going to be this linear shape. And since we're calling it linear, these 3 atoms are in a line, that means that we're going to have 180 degrees between these two angles. So if you have two atoms, two bonds surrounding a central atom, you get a linear shape, 180 degrees between the atoms. NH4 1+. How many things around the central atom? 1, 2, 3, 4. So that means that it is based on this tetrahedral shape, 4 things around a central atom. And for number 3, none of these things around the central atom are unshared electron pairs. So we're going to have 4 atoms surrounding the central atom. We're going to have a tetrahedral shape as our final shape, and the angles between each bond are going to be 109.5 degrees. Okay, you might be getting the hang of this. That's great. I'm going to do a few more practice problems because it is so useful to just keep going through these steps so that it becomes second nature. Every time you look at one of these Lewis structures to determine the Vsepr shape, you want to go through these 3 or 4 steps to figure out what it's actually going to look like. It should just become automatic. So that's why I'm doing these practice problems like over and over again, so that it can just become very natural and you won't ever doubt yourself when you're doing these sort of problems. Okay, SBH3. Number 1, how many things are there around the central atom? 1, 2, 3 bonds, 1 lone electron pair. So there are 4 things total around the central atom, and it's going to be based on a tetrahedral shape. Now, which atoms are replaced by lone electron pairs? In SBH3, one of these 4 things is a lone electron pair. So that means that its shape is going to be like this, because this lone electron pair replaces this atom. This is the trigonal pyramidal shape, and it's going to be an angle of 107 between these bonds, a little bit smaller than 109.5 of the tetrahedral, because this lone electron pair pushes these atoms a little bit harder than an atom would. O3, which is ozone. How many things are on the central atom? 1, 2 bonds, and 1 lone electron pair, 3 things total, which means that this is going to be based on a trigonal planar shape. Here it is. How many things are replaced by lone electron pairs? Well, instead of having 3 atoms, as in the trigonal planar shape, we're going to have 2 atoms and 1 lone electron pair. So this is the shape that I'm going to get. Here is a lone electron pair that replaces this atom, and that means that I'm going to have a... Where is it? Oh, there, okay. It is a bent molecule with less than 120 degrees between these angles, because this is pushing a little harder, angle of about 116 degrees. One more and then we'll be done. SeCl2. How many things are there around the central atom? There are 4 things. 2 bonds, 2 lone electron pairs. So this has 4 things total, so it's based on this tetrahedral shape. Which atoms are replaced by lone electron pairs in this molecule? 2 of these atoms. And because of that, it's going to have a shape that looks like this. 2 atoms from here. 2 of them have been replaced by lone electron pairs, this one and this one. Lone electron pair, lone electron pair. And this is also going to give a bent shape. And the angles between the atoms in this bent molecule are going to be about 105 degrees, because these lone electron pairs are pushing pretty hard against these 2 atoms. So that's what we're going to get. Anyway, these steps that I keep talking about are the ones you always want to go through every time you're looking at a Lewis structure and figuring out what the Vsepr shape is. Once you get the hang of it, it's really not that hard. You think about the structure that the molecule is based on, and then you just figure out how many of the atoms are not there, how many of the atoms have been replaced by lone electron pairs, and that will tell you what the final structure is. So keep practicing this, keep these steps in mind until it's just second nature and you won't have any trouble at all with these problems. Good luck.